So today we will be discussing experiment number two, laboratory number two of our E131. So this will be lab 2. So ito i-upload ko na lang siya sa MBLE. So here again, you can write your name, input your name here, section and date. So in this experiment, you don't need to insert figures. Wala na figure, you just need to fill up the data that is needed in the table. So this will be our objectives for this experiment. The main objective of this experiment will be we will implement approximation and calculate errors uh, written in a program in Octave. So discussion, ito na discuss na natin chapter 1. So what's an error? The true sources, major sources of errors, truncation and round of errors, true value error, relative error, true error, and so on. Then ito importante yung approximate error. Then the pre-specified percent tolerance or the stopping criterion, which is equal to 0.5 times 10 raised to 2 minus n, where n is the number of significant figure. Now, yung ginawa natin in chapter 1 sa lecture, we will implement it here in lab 2. So to do that, first we need a pseudocode. So what's a pseudocode? So this is the pseudocode. Example of a pseudocode. Pseudocode is the international language, programming language. So meaning it's not technically a language, but it's just a way to represent all the programming language so that every programmer, either uh, he or she is programming C++, Java, and so on, or different programming language, they can understand the pseudocode. So ito yung international language nila. Or another way is to do flowchart. So you can do flowchart before you do the actual programming. You do flowchart, or mas maganda, gawin yung pseudocode or the algorithm. So sa algorithm na to, sa pseudocode na to, nag-create tayo ng function. We name it iteration. And this function needs three inputs. So the input for x, so value ng ating approximation, ES is the stopping criterion. But later on, instead of stopping criterion, we will be using the number of significant figure. And we already know the formula of the stopping criterion in terms of the number of significant figure. Another uh, input is Imax. This Imax here, this means this is the number of maximum iteration, or the maximum number of terms, plus 1. So here, first we initialize, just like before, you do initialization, and after initialization, we can now do the actual code. So sa actual code, first we quit the old and the new because this is iteration. So the and the previous and the uh, actual, or the present present value. Then here in this part, in this part sa part na to, sa rest, dito natin ilalagay yung actual na equation, or yung equivalent na yung gagamitin natin is the Maclaurin series expansion in approximating some functions. It's like what we did in lecture 1, chapter 1. And after uh, putting the equation or the expansion, series expansion, we need to increment or increase the iteration by 1. And after we do that, first we check if do we need to stop the iteration or the loop. So there are two stopping criterion here. Uh, Either the approximate error is less than the stopping criterion, or the pre-specified uh, error, or either the number of iteration is reached, or na-reach na natin yung maximum number of iteration. So either sa kanila, so or means either one of them is true. If one of them is true, then we will break this loop, the do and end loop. Kung hindi pa na-reach yung dalawa, then you still go back here again, then you set again the old value, make it new again, the old and the current approximation. Then repeat that process and so on until you reach the criterion and stop it, and the iteration will be the result here. So that is basically the meaning of the pseudocode. So if you're a programmer, you can understand this code. Kahit anong programming language yung gagamitin mo, you can implement this one. But for us, we will be using Octave or MATLAB. It's the same syntax. So we need to implement this one into Octave. So to do that, we need an example. So this one, we will be using e raised to x. This will be our function, the basic function na ginawa natin sa chapter 1 sa lecture. So what do we want? We want to approximate this one using the Maclaurin series expansion. Then we need to approximate the solution up to 8 terms or 8 iteration or 8 plus 1 iteration. So it means 9 iteration. And also 3 significant figure when x is equal to 0.5. And the equivalent Maclaurin series expansion will be this one. Ito yung ilalagay natin dito sa resolution here. Result here. Okay? Okay? Mga dakpay? Makita yun? Nagawan? Mayat. So here, we want to implement this Maclaurin expansion of e raised to x. So to write the program, this will be our program. Ito yung gagamitin natin. I already write this one. So in this program, so let's just use the command window here. Go to editor, then write that code. So ito na yung code na gagamitin natin. So you can copy this one or you can create your own. So here I created the function, I named it iterate. Then this function will take three inputs, x, n, and sig fig. What is x? The value for x. If it's e raised to x, ano yung gusto natin value na x to approximate e raised to x. And here is the number of iteration or terms. Sig fig is the number of significant figure. Then next is we do the initialization. So I will start at I equals 0. So this means if I start at I equals 0, the number of terms will be added plus 1 because I started at 0. So if I take here, the result will give me 9 terms. It means the actual terms is 8 because I started at 0. Then here, I also put the formula for the stopping criterion, pre-specified stopping criterion. ES is equal to 0.5 times 10 raised to negative 2 minus the number of significant figure. So you need to put here, if you want to display this one, you need to remove the semicolon. If you don't want to display it, then you just put the semicolon. I just remove the semicolon para i-display niya yung actual value of the stopping criterion. Here I also put the value, the actual value, the true value of e raised to x. So this is a built-in function inside Octave. So that I will compare it with the approximate calculation with the actual value. Para kung gusto mo malaman yung true error, pwede rin. Nandito yung true error. Pero hindi ko siya i-display. Pwede siya i-display later on if you want. Then, these are all initialization. Sa Sir Old, I started with infinite, but you can use 100 if you want. This is the initialization value. So, mas maganda yung malapit na approximate value. But in actual, you don't know the value, so I just put it infinite. Then here, ito yung magiging pangalan na parang naka-table siya in column. So para malaman yung number of terms, results, and EA. So you can put your ET for the true error later on. Pero hindi ko na siya lalagay. Kaya na maglalagay. Kung gusto nyo makita yung true value. Pero constant naman yung true value. Hindi siya magbabago. Pero yung error na ER, true error, magbabago siya. And next, math, okay, Pi? So, okay, this will be our written program. So, we end up here. So, we do the while loop. So, the loop here is, the syntax is while. We can use other syntax. But generally, while is widely used as a syntax for a looping functions. So, here, first, I set the old or the previous value to the current approximation. We do this one so that we can continue the approximation, we can continue the iteration. Then, the next one is, ito yung ating equation for e raised to x. This is the Maclaurin series. Then, here, naglagay lang ako dito ng para hindi mag-error kasi kapag less than or equal to 0 yung value natin ng actual value ng result, magiging infinite or over 0 yung ating E of A. So, nilagay ko lang, hindi dapat ito maging 0. Then, if you want to include your true error, lagay nyo lang dito. Then, here, ipiprint natin, print F, yung actual command. And, ito mga percent na to, i-try nyo, tignan nyo yung syntax ng fprintf. I-type yung help, fprintf, then, ang ibig sabihin ng mga to is we set these values here para maging kung gusto mo naka-decimal or depende kung ilang decimal places and so on. Then ang gusto kong i-print here is the number of iteration plus 1. Plus 1 ako. So later on you need to subtract it by 1 para makuha natin yung actual. Then the result and the approximate error. I also want to print this one, the stopping criterion at the top. So, hindi ako naglagay ng semicolon. Then, after that, I add 1 to the iteration. Bakit ako mag-add 1? You go to the next term. So, you need to increase the term until you reach the certain stopping criterion. Then, when do we stop? When we reach this part, either when I is greater than n. So, the number of iteration is greater than n, which is the maximum number of iteration. Or if the absolute value of the approximate error is no less than the stopping criterion error ES, which is here at the top, can be solved using the input, the number of significant figure. So if either of the two, because these two lines here, this means or. So it means kahit isa lang sa kanila yung na-reach ng condition, then ang gagawin niya is to break the loop. So, nag-stop na siya. Pag nag-stop na siya, yun na yung final value. So, yun yung ating iterate. Ito yung ating function. Ganun yung gawin. Baguhin yung mga variables, baguhin yung pangalan. You can put any variables you want. Pero tandaanan nyo lang kung ano yung mga variables na yan. Kagaya ng n here, this is not number of significant figure, but this is the number of terms or iteration. While here is the number of significant figures. And to run this program, first you click this one. So sometimes, kung i-click nyo to, yung kung saan nakasave yung program is not the actual directory. So may mag-a-appear dito na change directory or add path. You just click change directory para gumana yung code. Kung hindi nyo ginawa yun, hindi nyo click to, hindi nyo chinek, when you run the program, hindi siya gagana. So you need to run this one. Or press F5 if you want. So to run that one, so iterate. Then we need to input three values. So what are those three values? So here, x. What is the value for x? So I want my x to be equal to here. So ito example natin should be 0.5. So ilagay ko dito 0.5, comma. Then the next value should be n. What is n? The number of terms or iteration. So sa problem, we need 8 terms or 8 iterations. So I put here 8. Then lastly, ano yung last part? Sig fig. Ano yung sig fig? Number of significant figure. So ilan yung significant figure? Up to 3 significant figures. So I put here 3. Then we click enter. And ito yung lalabas. So here, naka-print yung ating stopping criterion, which is 0.05%. So kung lagyan nyo ito ng semicolon, then try to save. Then you run this again. Mawawala yung ES or yung stopping criterion. So yun yung ibig sabihin ng semicolon. Hindi niya i-display or mag-stop lang siya. Pero gumagana pa rin siya. Nasa loob lang yung calculation, hindi lang niya i-display. So, do this again. Hindi ko na save. We need first to save, then run. So, ayan. So, 0.05. So, ano yung unang na-reach niya? So, kung mapapansin natin, 100 yung nakalagay na EA sa first iteration. Why? Because yun yung initial value natin. Because 0 muna. 0 yung previous na value. So, magiging 100% siya. So, 1 over 1 is equal to 100. So, in actual, wala to dapat sa column na to. So, NA dapat yung nakalagay dyan na value. You only have the actual approximate error sa second iteration, which is 33.33%. Then, mag-increase siya up to yan, 1.64. And if I want to print yung true error, ay true value, try natin i-print yung true value. Then, let's compare it. So, yan. So, ito yung actual 1.6487. 1, 2, 3, 4, 5. 5 significant figures. So, if we compare 1, 2, 3. So, tama na yung 3 significant figure. Na-reach na natin yung 3 significant figure. Actually, hanggang 8 pa siya. Hanggang 4 significant figure. So, sa 5th lang, medyo hindi na siya accurate kasi 6 and 7. So, we stop at the 6th iteration and we reach 4 significant figure. You only need 3. Why? Because of the formula. Itong formula na to is meron siyang allowance na isa pang significant figure. So, yun. Ngayon, next is we will do this again, but this time instead of e raised to x, we will use cosine of x, and the equivalent will be this one. This is the equivalent series expansion of cosine x. Now you need to implement this one using, so here yung values na makukuha nyo at this part, ito 1, for example, this is 1, ilalagay nyo lang siya here. So 1.000 and so on. You do this until, because it's 8 up to 8 terms or 5 significant figure. So kung kulang yung table, yung row, insert nyo na lang. Gamitin yung PDF scape na diniscuss ko kanina. Okay? So, that's the approximate error. Lagay nyo dito. Then, again, meron tayong questions that you need to answer. And also, lastly, the conclusion. Then, save this one. You need to save and send it to MPL. So, that is lab 2. Any question?